First one we'll consider for the inverting amplifier. Okay, for inverting amplifier we can draw the amplifier diagram like this. As it is known as inverting, so voltage would be connected with the negative terminal, so I'm connecting the voltage V1. Another terminal would be grounded and the positive terminal would be grounded, and there is a feedback resistance which is connected with the negative terminal only. That feedback resistance is denoted by RF. This one is denoted by R1. V naught is the output voltage. So according to this, V naught output voltage would be how much? V naught would be equal to minus of V in RF divided by R1. So this expression you need to learn it. Output voltage would be equal to the input voltage. And why there is a negative sign? Because that voltage is connected with the negative terminal, so that's why we'll get negative in the output voltage as well. Okay, next one diagram is for the non-inverting amplifier. In the non-inverting amplifier we'll get a diagram like this. As you know, non-inverting, so in this case voltage would be connected with the positive terminal, right? V in. Another terminal would be grounded. Okay, again there is a feedback resistance, and feedback resistance is always connected with the negative terminal, so I connect the feedback resistance with the negative terminal, and there is a resistance R1 over there, and we'll get the output voltage. Now in this output voltage formula is how much? V naught is equal to V in 1 plus RF divided by R1. Okay, so V in is the input voltage. As you can see that we have connected with the positive terminal, so our sign is positive only. Next one is the voltage follower. In the voltage follower we'll get the same input, same output, but we'll get, you can write down later on, first understood it. Okay, in the voltage follower will give voltage to the positive terminal, that is V in. Okay, negative one is connected with the feedback resistance, but as you can see that feedback resistance RF is in this case is 0, and this is the output voltage, so we'll get output voltage would be equal to the input voltage. As you can see that there is no resistance feedback, RF is also 0, R1 is also 0. So this is the special case of non-inverting amplifier where RF is equal to 0. Next case is the summing amplifier. In the summing amplifier basically we'll use it as a adder. We can use two or more than two voltages. So again I'm using op amp. It is connected with a negative terminal, and as I told you we can use more than two op amp, like this is sorry, more than two voltage. So here I am using 3 voltage. Suppose this one is V1, this one is V2, and this one is V3. Another terminal would be obviously the grounded. Positive terminal would be also grounded. Here the resistance we can consider R1, R2 and R3, and there is a feedback resistance also. Feedback resistance is denoted by RF, and the output voltage is denoted by V0. So in this case we'll get the output voltage V0 by the formula minus of V1. Okay, why we have said minus? Because we have connected with a negative terminal, so minus of V1 RF by R1, then minus of V2 RF by R2, then minus of V3 RF by R3. So this is the final output. Why it is negative? Because we have connected with a negative terminal, so every time basically it is a negative. Or we can write down like this also, V0 is equal to negative of V1 RF by R1 plus V2 RF by R2 or V3 RF by R3. Okay, so if they consider RF, R1, R2, R3 all resistance are equal. Okay, let us consider RF is equal to R1 is equal to R2 is equal to R3. Then in that case output voltage would be minus of V1 plus V2 plus V3. Okay, as its name a summing amplifier. Summing amplifier means the adder when it is adding the voltages. Okay. Next one is the difference amplifier. In the difference amplifier, as its name suggests, it is subtractor. Okay. For that, the diagram would be like this: negative, positive. We have provided both the voltages. One voltage will provide with the negative terminal, and one voltage will provide with the positive terminal. Okay. So that is, let us consider we have provided here V1, another terminal would be grounded. Here let us consider we'll provide V2, another terminal would be grounded. And again, obviously there is a feedback resistance which is connected with the negative terminal, that is represented by RF, and output voltage is represented by V naught. Here one more resistance is there. This is like R2, this is maybe R1, and this is maybe R3. Okay. So as its name suggests, difference in the amplifier, when where will be the difference? If we'll give 2 voltage, right, then only there will be the difference. Now if I'll give 1 voltage, then there will be no difference, correct? So in this case, what would be the output voltage? Output voltage is formula is V1 into R3 divided by R1 plus R3 and 1 plus RF into R2 minus, like this is basically minus, then V2 into RF by R2. Okay, what they have done actually, see, this is the output voltage when we consider the voltage V1 only. Remember the superposition theorem? In the superposition theorem, we'll only consider one single source at a time, right? Another source would be neglected. So if I'll consider V1 only, then this would be the output voltage. Okay. If I'll consider V2 only, then this will be the output voltage. So both would be subtracted with each other. So the final output voltage, if I'll consider RF is equal to R1 is equal to R2 is equal to R3, then V naught would be equal to V1 minus V2. As its name suggests, it is the differential amplifier, so both the voltages would be subtracted with each other. Okay. Next case is that op amp will work as a integrator. As its name suggests, there is an integration for this case. We'll draw the op amp. Again, we'll connect with the negative terminal, and then instead of feedback resistor, we'll use as a capacitor as a feedback. Okay, so that's why it is denoted by CF. CF is for the feedback capacitor. There is a resistance R, and here we are providing the voltage V in. Another terminal would be grounded, and positive one also would be the grounded. Here the output voltage is represented by V naught. So final output voltage is minus. Why minus? Because we have connected with the negative terminal. 1 over RC is it is an integrator, so integration of the input voltage. Input voltage is V in, and limit vary from 0 to T dt. So this is our final output for the V naught. It is even it will use as a integrator. Next one is will use as a op amp as differentiator. Okay, when op amp will act as a differentiator, then in that case differentiator, obviously there is a differentiation, but the diagram would be exactly opposite to the integrator. Here we are using the capacitor as a feedback, but in this case we'll use capacitor as the input and feedback as the resistance. Okay, in this R and C is there, but in this case we are using C and R. Again we are providing the voltage, input voltage to the negative terminal, other would be grounded, positive terminal would be grounded. This would be the for R V naught. V naught value is this in this case it is connected with the negative, so negative RC, it is a differentiation, so that is d by dt of the voltage, input voltage, dv in by dt. So this is the final expression for the op amp as a differentiator. Got it?